Hi everyone, my name is Stanley Wang and I'm a data scientist at SEGA Europe. So SEGA have quite a rich history of making video game consoles and software alike. You might have remembered the SEGA Mega Drive or the Master System of the 90s. Did anyone own one? Just out of interest. Great, lots of hands up. So not only did they make a lot of consoles, but they had a lot of games with those consoles, lots of iconic franchises such as no other than Sonic here at in the back. And recently though, Sega's had a bit of a transition, SEGA Europe at least. So nowadays SEGA Europe is a video games publisher, and we work with a lot of amazing studios around the world, such as Creative Assembly, who do the Total War series of games, the historical strategy games, Sports Interactive, who make the Football Manager series. We work with Relic Entertainment from Canada, Amplitude Studios from Paris, 2 Point Studios, and HardLight, who do mobile games as well. So there's a ton of variety, and all these studios make such different games, but they have their own fan base, and we're all really aligned on kind of one common goal, which is to create amazing games that are fueled by the community. So before I get started a bit on what we do in terms of data science at SEGA, I just want to briefly share with you my background, why I kind of fell in love with data science, and why data is so important for the video games industry now. So I'm from Edinburgh, actually. I've lived in Edinburgh all my life. You might not believe me because of a lack of a Scots accent. I promise I am. And I graduated from the University of Edinburgh 2 years ago. And during that time, I was quite fortunate because I took on a project that involved a lot of machine learning and AI techniques. It was actually, the project was trying to recognize human emotion from recorded samples of speech. And I just thought at the time, using all of these techniques and applying them in the sense of audio waveforms was just the coolest thing ever. And it was innovative, it was cutting edge, and it was really challenging at the time. And those are the three exact phrases that I would use for the field in this current state of time as well. So why is the video games industry in need of a data revolution? Well, not so long ago, SEGA, as well as many other companies in the video game industry, they were releasing box products. So that's physical copies of CDs that they would distribute to retailers who would sell the games. Now, the life cycle in the development of games for box products was very different. When a product was released and it reached us on our shelves, the development would essentially grind to a halt there. There would be no need to constantly maintain the product or release new iterations of it. Nowadays, though, SEGA have made a huge transition from selling physical products to digital distribution. And now digital makes up the bulk of our product sales. The difference with digital distribution now is that games are constantly being developed, improved. There's patches, bugs, fixes. Additional downloadable content is constantly being released for a game. So it's an ongoing development process, and the life cycle of a game now extends to years and years beyond the initial release of the title. This is where data is key, because we need to use the data that we collect in order to inform our decision making for this process. Feedback from the community is essential to helping us really understand what kind of content our fans actually want, and not just releasing something that we think they want. So in this presentation, I'm just going to go through the kind of data that we collect at SEGA, just a brief overview of that, and then some examples of data science projects that we've been doing in the past year at SEGA. Some of you might have been in my colleague Felix Baker's presentation earlier today. Felix is the data architect at SEGA, and he talked in a lot of detail about our data platform, the architecture behind it, and how it is we collect the data. It was a really interesting presentation, and I'm not just saying that because he's my boss. But yeah, it was really insightful. But for time's sake, we're going to just do a brief overview of the kinds of data that we collect. So on the right-hand side, you'll see that we collect sales data, and this is collected on a daily basis. So sales data ranges from Steam, PlayStation, Xbox, Apple, Android, and potentially in the future Google Stadia as well. And it's not just sales data we collect here. We collect wishlist data, users' playtime, reviews, whether it's positive or negative on any particular day, and app ownership. We complement this sales data with in-game analytics. And we've got a data platform that takes in over 7,000 of these events per second. And we work very closely with the studios and the developers to understand what type of data they would like collected from their game and what would be helpful for us to perform analysis on. So we put hooks within the game before the release of the game that track certain events once they happen. So for example, with Football Manager, we have an event that tells you when a match is played, what the result of that match is, what tactics both the teams used, and how that affected maybe the league position. Whereas for something like Total War, we might have an event for when a battle is concluded, whether the user was victorious or defeated. And for Sonic Mania, it could just be something as simple as an end-of-level event, where we collect how many rings they managed to collect during that level, and what their time was for that level. So we've got all this data now. Now, how do we use this data in a way to kind of enhance the customer experience? So I've got an example here for you, and this is quite an exciting project that we're working on. This is a screenshot from a game called 2 Point Hospital. Some of you might have heard of this game. It's a hospital management simulation game with a very tongue-in-cheek kind of aesthetic. I believe a lot of the illnesses that you have to cure are kind of puns of medical symptoms. I think there's one called lightheadedness, where your head actually gets replaced by a light bulb, and you have to unscrew it and screw the original head back on. But as you can see with this game, it's a very popular game, and it's by one of our recently acquired studios, which is 2 Point Studios. And 2 Point Studios wanted to know how it is that players actually played the game, because rather than basing it on their own assumptions and bias about the game, we wanted to use data as the evidence for working out what kind of player behaviors are statistically significant within the game. So we worked very closely with 2 Point Studios to develop a clustering algorithm that would help them segment players based on how they played 2 Point Hospital. And this was beneficial in many ways, but ultimately it helped us gain a better understanding of our own fans. And in turn, we could release new content for 2 Point Hospital that would actually cater to what they wanted. So I talked more about this clustering player behavior. So aside from 2 Point, just kind of briefly go over what the general objectives of clustering would be. So when we decide to cluster data points, what we're trying to do is we're trying to discover structure and hidden patterns within very high-dimensional data. So if you think about the amount of events that we take in, each of those events could be a feature in our model. This can range up to 20 or 30 dimensional models, which are very complicated for any analyst around the business to just look at with the naked eye and try and form connections. Ultimately, we want to group this data into similar patterns and cohorts, and in this case, it will be based on how we think players actually play the levels. And finally, this data needs to be made available to analysts around the business, to developers at the studios to help them refine the game. So the point of clustering here is to reduce the complexity of our raw data that we get in, and manipulate it to a form that is intuitive and can easily be digested by the rest of the business. So as I mentioned earlier, we take in a lot of events, many thousands of events per second, and this is growing, by the month. Some events that we take in for 2 Point Hospital include very broad level events, such as the average net income per hospital that a player achieves, the number of stars earned. So I think in 2 Point Hospital you have a maximum of 3 stars per level, and that depends on how many objectives you complete on each level. So it's an indicator of how well you do on each level. We can then drill in a bit further, and we can look at average patient and staff morale in each of those hospitals that the player controls. Their kind of cure to fatality ratios, hospital reputations, and we can even drill further into what kind of furniture people like to buy to decorate their rooms. So these are all potential features that we could use in our model. And the one thing we need to be careful of is features that have high correlation between one another, because essentially they're telling us the same story. So we found that net income and average balance were providing essentially the same information. So it doesn't make much sense to include both in the model. So we've got our model, we've got our data, but we need to work out now what the performance measure is. So what actually makes a good cluster? So you see here we've got kind of the data clustered into 3 different cohorts, with the black dots signaling the centroids of each cluster. There are 2 different types of performance measures that we want to consider in order to find out what makes a good cluster. One of them is called the within group variance, and you can think of this as taking the distance between each point and the central of that cluster, the centroid of that cluster. We want to maximize this number because it means that for all data points within one cluster, we want those data points to be as similar to each other as possible. The second measure that we consider is called the between group variance, and this is taking the distance between each cluster centroid to another cluster centroid. And this is a measure that we want to try and minimize as much as possible, because this essentially creates well-separated clusters. If we minimize this distance, the clusters are more distinguishable from one another. It helps the analysts to create more of a narrative and backstory to why these clusters came to be. So what are the results of our current clustering experiments? So after running it through a clustering model, and we found these results, we found that 4 clusters seemed to be an optimum number. So we took the average values of these 4 clusters, and we gave them to the analysts that requested this. And we worked very closely with the analysts to create a backstory for each of these clusters. And this was the fun part, coming up with names and how we think people actually played the game. So they're not technical terms, they're kind of just terms that we thought best described the players. We found that the majority of our player base, almost 40% of players, were what we called the flirters. And what this means is, on average, we found that they achieved around about level completion of 10 to 20%, so not far into the level. On average, they completed around 2 or 3 levels out of 15. We also found that their stats for each hospital, in terms of their income, their reputation, was generally quite good, actually, compared to some of the other cohorts. So they're not getting that far into the game, but they seem to be doing quite well on each level. They seem to be engaged, but possibly to the point where they're only really looking to try out the game for a short period. Perhaps these are the people that we picked up on promotions or free weekends. So it's worth actually drilling further into the data to see how it is that we acquired this group of players. And these further questions are only really made possible by doing this cluster analysis. We found the next biggest group were the coasters at 24%. And we called them coasters simply because they they coast through the game. They make it to about halfway through the game, but none of their stats look particularly impressive. On average, they only earn about 1 star in each level, and it seems like they're just doing the bare minimum they can to get through the game and see as much of the game as possible. We found that a lot of the coasters also dropped off the game at around level 6, which is about 40% of the way through the game. And I know that during this point, there is quite a big difficulty spike within the game. So a lot of people who are just kind of on autopilot and trying to get through the game tend to get frustrated at this point and leave the game. We have also the perfectionists, which I think I belong in this category actually. But we found that these perfectionists, surprisingly, they don't actually make it that far. They make it about the same stage of the game as the coasters, about level 6 out of 15. But that's where the differences kind of end. So the perfectionists, they've got a huge net income on each level, and we can see that they spend an awful lot of time on each level, completing every single objective, every minor objective, and really decorating their hospital to make it look as nice as possible. So these players, they're not interested in making it to the end of the game and completing the game. All they want, and the most fun that they get out of the game, is to try and make their hospital as best as possible. And finally, the polar opposites of those are the quick completionists, who we found made it most of the way through the game, about 80 or 90% through the game. And they're very similar to the coasters in the sense that they do the bare minimum to make it that far. But they're obviously very good and skilled players because they make it through a lot of the later difficult levels. They make up 16%, so it's the least frequent of our cohorts, but I think still statistically significant enough to be included here. And now that we have these cohorts, the really useful part of this is that we can actually personalize interactions with these cohorts. So if we think that there are a lot of flirters in our player base, and these flirters are quitting by level 2 or 3, we can send them a personalized promotion to help them, keep the incentive up and try and keep them playing the game, maybe by sending them a free item in the game. Whereas for the quick completionists, we know that they've completed all of these levels, so there wouldn't be much sense in sending them these incentives to keep playing. What we would do then was heavily promote any additional downloadable content we have for the game that adds new levels and new challenges. Those would be the group that will respond best to that promotion. I think this has died. I can use the laptop actually. Right. So we complement the analysis of in-game cohorts by also working with the consumer research team in our office, and we help them come up with questionnaires to send out to gamers of multiple different platforms, so PC gamers, console gamers, even just people that play the odd game here and there on their phones. And we kind of come up with questions for these gamers that give us a bit more insight into their gaming preferences, their spending habits, other interests outside of gaming, attitudes, brand knowledge, and a lot more. And the benefit of this is that we complement this data with our in-game reports. And it's really key for us to spot trends early, which informs us of any decision-making for newly released games, and just help us gain a better understanding of our players. So we also, in addition to these survey questions, we use them to create what we call gamer personality profiles. So we have certain questions like, we have a statement, for example, gameplay that builds suspense. And you have to rate that on a scale from 1 to 7 on how much you like that feature in a game. And we try and collect kind of similar statements together to create a score for that type of personality. So, for example, a buzz score would be how much that person enjoys kind of action, a thriller, kind of a lot of first-person shooters, I think, belong in there as well. Similarly, we've got like escapism, which is kind of fantasy elements. How much do you appreciate the storyline? How much do you appreciate character development in the game? And finally, like creativity. So how do you like to customize your looks? Any gears or vehicles that you have? Like how much do you like your own personality and creativity reflected in the game? And these are just 3 examples of personality scores that we have. We actually have about 15 of these different ones that we can include in our analysis. And what we do is we serve the results of these clusters and reports and analysis to the rest of the business in the form of dashboards. And we use Power BI a lot in order to kind of distribute the data to the rest of the business. So here's an example of a cluster analysis dashboard where you can just select the cluster that you want, and it will give you kind of an average score of how they answered each type of question in the survey. So at a quick glance, you can see differences between groups very intuitively. And this is kind of along the same idea. So you've got the clusters on the x-axis, and you've got how much they'd be willing to spend in pounds for certain types of platforms, such as PC, console, and mobile. And immediately, through just one glance, you can see that there are quite distinctive contrasts. So before I move on to the next project that we work on, I feel like it might be worth just mentioning what Steam is, because some people might not be aware. Who actually uses Steam or is aware of Steam? Okay, quite a lot of you. So so Steam is a digital distribution platform for playing PC games on. It's the main way that we actually make sales, and all of Sega's titles, both past, present, and future, will be available for everyone to purchase on Steam. But a common feature on Steam and any other marketplace or e-commerce website is the ability to add a game to your wish list. Does anyone actually use this feature on kind of Amazon or anything like that? Not that many people. Does anyone use wish lists, like add a product to their wish list and then completely forget later that they've added it? Yeah, I do that all the time. So this is actually quite an interesting line of research, because we have over 40 million wishlist additions on Steam for Sega products. And this represents a massive pool of potential revenue that historically isn't really being factored into any forecasts. But if we can ask the question, out of these additions, how many will end up buying the game at a later date, then that would be a really useful tool for the business to use. So we tried a lot of different models for this. We tried a decision tree boosting algorithm and a feed-forward neural network. And we kind of tried to pick the best performing model based on both model accuracy and the time it takes to train. When a user adds a game to their wishlist on Steam, there's kind of 4 possible outcomes that can happen at a later date. They can end up buying the game, in which case we count that as a successful conversion, so we can give this a positive label. They might have deleted it at some point from their wish list, in which case we can probably assume that they're not particularly interested in buying the game, and we can label this the opposite. So someone could add a game onto their wish list, and we have no further record of what happens to that game and that activity on their wish list. So it's still active on their wish list. They've probably forgotten about it. What do we do in this instance? We just set a threshold of, say, 6 months. And if it's still active on their wish list after 6 months, then we're just going to assume that they've forgotten about that game and they're not interested. If that wish list period is still within 6 months, we'll remove them from the data set, because we cannot be sure what they're going to do with the game. The 4th outcome is they could have added it onto a wish list and then received it from someone else as a gift. And we also remove these from the data set because we're only interested in people who kind of voluntarily convert from their wish list additions. So in that sense, we kind of modeled this problem as almost like a binary classification problem, where the target is either a 1 or 0, depending on whether we think they're going to convert at a future date. And again, we've actually created this model, and we We serve the models out to the rest of the business, and we're constantly looking for kind of feedback on how to improve the model itself, but also the display of the models. But here is another Power BI dashboard where you can select your game at the top, and it will tell you the number of total wishlist additions for that game up until the present time, and the number of predicted conversions for that game. And we've got the conversions as well on the bottom left, where it's separated by different time range variables. So release, 3 months, 6 months, and 12 months, if you can't see that. We also have a guideline on historical kind of discount bands that people normally buy a game for. So a lot of people, you can see, buy Total War Three Kingdoms at full price. But if we say we wanted to have a promotion and we wanted to have the game at 50% off, we can get a general gist of how many more people we might encourage to buy the game based on what kind of promotion we do. We can also overlay the predictions onto actual wishlist data, so we can go into our database and find the actual number of additions and conversions over a specific period of time, and then overlay our predictions on top of that just to see how well we're actually doing. And by doing this, we actually explore a new avenue of modeling. We can actually turn this from a binary prediction model to a time series forecasting model. And the benefit that has is that it gives us better flexibility on choosing promotion dates and how much discount we want to offer them on that promotion. Beforehand, we only had kind of fixed time ranges of 6 months, 3 months, 12 months, but now we kind of, using this way, we're a lot more flexible. So there's plenty more to come in terms of data science at SEGA. It's still very much in its infancy, and I've only been at SEGA for a year, and that's essentially the time frame that we've had to kind of try and develop the foundations of like a data-driven platform. But there's so many exciting projects that we've got lined up that we haven't quite yet managed to find the time for. But so all of these projects are beneficial in their own ways to the business, and we've got started on some of these. We've actually got a sentiment analysis tool that manages to scrape Steam reviews for any game that you're looking to analyze reviews for. Scrapes all the Steam reviews and works out positive, negative sentiments, keywords that contributes to those sentiments, and it also translates reviews in other languages to English so that we have a more complete data set. But it also labels that review with the original language, so you know that perhaps a lot of negative reviews come from Germany, for instance. So that's pretty much an overview of data science at SEGA. As I said, there's so much more to come, and there's so much more that I have to learn as well. So I'd love to get to speak to you guys afterwards, learn about kind of your data journeys, your experiences, and the challenges that you've had to overcome. But it's been a real pleasure, so thank you very much, everyone. Thank you.